Hello guys, welcome again to the series which is on machine learning fundamentals. We're at a very important juncture. In fact, we were discussing about unsupervised learning models, and in that, in fact, we had discussed advanced hierarchical algorithms, and after that, in fact, there was a discussion which was on the ensemble methods that are there, and we had discussed ensemble as well in quite a detail and what for we are using ensemble. Now, this particular point, I think the viewers who are there, they are ready, and they should be in fact ready to take some concepts that are related to reinforcement learning. So one of the very important machine learning applications and types, which is in fact reinforcement learning. It is having a wide variety of application. In fact, in numerous application areas, and very important ones, reinforcement learning can be used, and it can yield significant benefits. So we are going to take this reinforcement learning in a little bit detail here, bearing the fact that there are numerous algorithms that are in this category. I'll be showcasing you just the listing of those algorithms, but a few of them, in fact, in this particular series, in this episode, which will be 17th. In this, it is, I think, last by the final episode for this series. So probably we'll be concluding in the next episode, which is there, this series, which is on machine learning fundamentals. Then there will be specific series coming for different application areas in which we'll be taking things in quite a depth, and that will be limited to those algorithms, those machine learning, algorithms that will be used specifically for those areas. Anyways, coming back to this reinforcement learning, as we are saying, very important. And in fact, I don't think this is going to be sufficient, whatever information we are going to give, bearing the fact that this is a very huge area. Lot of implementation, areas, application areas for this. And this will be just a start, but you have to make a start definitely. So we'll be making a start for this reinforcement learning, discussing 2 to 3 different algorithms there, and then certain concepts which are there related to this, those also will be discussed. So let me just put this presentation, reinforcement learning, in front of you. So this is Dr. Zam's AI and cybersecurity platform, a free platform for everyone who wishes to learn artificial intelligence, machine learning, and cybersecurity concepts. So this is a free platform, which is available to each and everybody. And in fact, those who are interested in learning artificial intelligence, cybersecurity, machine learning, and the related concepts that are there. So this platform is going to be very useful for you. So do subscribe to the channel in case you're feeling that it is beneficial for you. So whenever a new video is uploaded, you'll be getting intimation for that. So let us continue with this reinforcement learning, a very important topic in machine learning, one of the major areas in machine learning, in fact. So what is reinforcement learning? In fact, we had given the basics of it. Reinforcement learning is learning through interaction with environment to maximize reward. So what reinforcement learning is actually, it is learning through environment. So in a particular environment, it will be deployed, and then learning will take place. And reinforcement learning is having two mechanisms. If you are doing something correctly, it will reward you, and if something is done incorrectly, it is going to penalize. So reinforcement learning is a machine learning paradigm in which an agent learns to make decisions. So agent is making, in fact, decisions, and by interacting with the environment. So agent is there, which is in fact making decisions, and then that agent is actually interacting with the environment. So there will be definitely an environment in which it will be working, and it receives the feedback in the form of rewards, and with the objective of maximizing cumulative reward over time. So definitely it will be receiving a feedback with penalties and rewards. So if a reward is received, so it will try to maximize similar kind of things in the future as well, so that those rewards can be in fact maximized. So cumulative reward which is earned for a particular environment through a cycle, it will try to enhance that cumulative reward over time. So this is what reinforcement. This is not the first time we are discussing. We have discussed reinforcement learning in a very basic form when we started this series on machine learning fundamentals. At that time, we discussed that three major categories of machine learning, which is supervised, unsupervised, and reinforcement learning. And at that time, we had given definition, basic definition of this. So the simple understanding of reinforcement, the system learns by trial and error. So this is a trial and error method in which you are taking an action, or agent is taking an action on an environment, and then it gets a feedback whether that action was correct or it was incorrect. If it was correct, then the reward is received. If it was incorrect, there will be a penalty. So this mechanism of trial and error, so that in fact is very beneficial in learning that for the future, that what action should be taken. Takes an action, observes the result, gets a reward or penalty, improves its future decision. So definitely when you are receiving future penalty or a reward, so based on this previous experience, the future decisions can be taken, which probably will be earning then the reward. So this is actually the logic behind reinforcement learning. So there is a real life analogy in this, definitely. So if you have to correlate it to the real life situation, so what that can be. For example, a video game is there. Player is trying. So we play video games, and we are trying to actually get things right. Or for example, there is a car game in which I am driving a car. So I try to get the car, go through a race without any accident, and then reaching at a number one position. So as I'm going on doing it again and again, I will be just receiving rewards in the form of it might be a game over, or I'll be just getting reward by completing the levels. So as more and more games are played by me, so I just learn how to drive this car. So this is actually something very common. Player tries different moves, wins, that means he's getting rewarded if he's winning the level or winning the race. Loses, that is a penalty. So if player is losing, it's a penalty, and it's in fact both the things are the learning for the player. So player can be thought of as an agent, so who is learning through penalties and rewards. And player is learning the best strategy to in fact earn the rewards in the future, and win the race or win the game. So that player is that the agent, and in fact the video game is the environment in which it is done. So this is a very appropriate example, real life example analogy that can fit into the reinforcement learning. So this is exactly what happens. So key differences from other learning types, key differences of reinforcement learning if you're comparing it with other types that are there. If you just see learning type and learning style and data, supervised, it is labeled data and learn from examples. Definitely unsupervised, it's unlabeled data. It finds patterns that we have seen both of them. And reinforcement learning, it is learning by interaction, so it learns by rewards. Rewards or penalties, whatever you call it. So learning by rewards, learning by penalties. It is that is reinforcement learning. And the core components that are there of reinforcement learning, what are those? So there's an agent, there is environment, and third one is states. There are a few more. In fact, we are going to discuss them all. So what is an agent? The learner or decision maker is an agent. Example is robot. A robot is an agent. Game player is an agent. Autonomous car is an agent. So these are all agents. And environments definitely can be different. Everything the agent interacts with is the environment. For example, game world can be environment, a road can be environment, simulation can be environment. So all of these are environments. Then state. So current situation of the agent is the state where current agent is. What is the state of the agent currently? That is the state. Example is position of the robot, which is current position of the robot, and current level in the game is the status or the state of the agent. And then if you just see, action is one more core component of reinforcement learning. What is that? What the agent can do. So what an agent will be able to do. For example, in certain examples, for example, this robot can move left, it can move right, it can move forward. So these are the examples. It can accelerate, it can jump. So these are some of the actions that can be taken. The same manner in the game as well, a lot of actions can be done by the gamer, or who's the player. So depending upon the environment. So reward, what is the reward? Feedback from the environment is the reward. For example, +10 for success, -5 for failure. So these are penalties and rewards which are there. And the policy, which is spy strategy used by the agent. Given a state, what action should I take? So current state is this one. What will be the next fruitful action that I can take, which will be attracting a reward. So the goal is there, maximize total rewards over time, which we are saying cumulative rewards which are there. So over time, the rewards which are there, they should be maximized. That is the goal. And these are in fact the core components of the reinforcement learning: agent, environment, states, action, reward, policy, and goal. So I hope that very simple to understand here up till here. Basic reinforcement learning cycle. So what happens exactly in reinforcement learning? Agent observes the state. So first of all, there's a process. Agent is observing the state. Agent takes action. So definitely agent will be taking action. Environment gives reward. So based on the action, whatever was taken, if it was an appropriate action, it will be rewarded. Reward can be in both cases, whether it is appropriate action means it is a right action or a wrong action, the environment will be rewarding. It will be rewarding negatively or positively. It can penalize, it can give plus points or negative points. Agent updates the knowledge, repeat many times. So definitely when it gets a reward, whether that's a penalty or a reward, it will be accordingly updating the knowledge. And definitely these if the mistake has been done, that will not be repeated. If it was a correct step and the reward was achieved, it will be trying to do the similar kind of a thing in the future as well. So it repeats this many times. So there is an example of maze problem is one of the examples that fits into reinforcement learning. If you just see, there's a scenario. What is the scenario? Agent starts at position A, goal is to reach G. So I'll be showing you this maze problem. Obstacles are obstacles sorry, excuse me. Obstacles give negative reward. So definitely if there are any obstacles, that will be giving the negative reward. If there are in fact learnings, that will be positive. So if we see this scenario again, we can just see agent starts at position A, goal is to reach the position G, and there are obstacles. Obstacles give you negative reward, and then definitely if you're reaching your goal, it is +10. If you hit the wall, that is -5. And every step when the step is made, so that also is in fact giving some penalty, because it should not be too many steps as well. So you have to just definitely find the shortest or a minimum path which is there. So move step, that will be -1. With every step you will be having -1. So what learning actually takes place initially, what happens is random moments will be there. So once random moments are there, then in fact there will be rewards, there will be penalties as well. But after learning, what will happen is the shortest path will be learned, because with those penalties and rewards, the model will learn the shortest path, and it can go through this, from one point, from the starting point to, and it will reach its goal. So if you just see this, maze problem, we are going to in fact see this and in fact implement that as well, and we'll see how it is happening in a very closely. We'll be in fact dissecting this all, in fact showing in Python, and each step with stepwise explanation. And then there is this concept which is exploration and exploitation, very important in this reinforcement learning. Exploration is, it tries new actions. So when it is trying to do some new action to see whether this is gaining the reward or the penalty. Trying a new path. So for example, a robot is trying a new path, or from one point to another, when the navigation happens, new path is being tried. So this is exploration. Exploitation, on the other hand, is use known best action. So you are using the known best action that you already done. That means taking the shortest path. That means it has already learned. Now it is in fact, going through that particular path which it has already known that this is the known best action. So key trade-offs: balance between learning and new things and using known knowledge. So definitely you have a balance between the two, the exploration and exploitation, because the new knowledge also should be gained. That it should not be remaining stagnant based on the previous steps which are there. So new learning also has to take place, but there has to be a trade-off. There has to be a balance between the two. Value-based learning certainly measures how good a state is. Value function, it measures how good a state is. Action value function, Q function, measures how good an action is in a given state. And then intuition, if I'm in this situation, how good is this action? So based on whatever situation a particular agent is, how good is it to take this action, and what it will be giving me. So that is intuition, in fact. So this is a value based learning. Core algorithm is actually Q learning. So you'll just see, based on this, in fact, you will be having a algorithm as well. We'll be going through that. So this is the core algorithm. In fact, it is used in many of the reinforcement learning models, and some of those in fact we are going to discuss as well. Q learning is a method that learns the value of action without needing a model of the environment. So it learns the value of the action. So a method that learns the value of the action without needing a model of the environment. So it does not need any model. It is just learning that this action is going to, what will be the value of this action. So for example, Q table is like this. S1 is the state, left is 0. That means this action is having 0 value. Right is 5, up is 2, and down is 1. So it stores values for each action. So it is storing the value for each of the actions, and what is the value of this action, right? So the core algorithm which is here, so it is just saying current value, the QSA, R is the reward, S is the next state, alpha is the learning rate, and in fact, there is a discount factor as well. We are going to discuss this in quite a detail, after 1 or 2 slides. So we'll be just going through what is discount factor, what is learning rate, so in detail. Simple interpretation: update knowledge based on reward and future potentials. So definitely we are having update knowledge based on the reward and the future potential. So it will be definitely updating the knowledge based on whatever reward and the potential of this in the future as well. So if you just see applications in the real world, so you can have a lot. So for example, a real world use case will be robotics for reinforcement learning, autonomous vehicles, game, AI, chess, a lot of the other games which are based on artificial intelligence, recommendation systems, finance, trading strategies. So in finance, we can have this trading strategies, cybersecurity, defense systems. A lot of other implementations are there for as far as the applications of reinforcement learning are. Very few are mentioned here. So strengths and challenges of reinforcement learning requires many iterations, computationally expensive. So this is very, computationally expensive. So difficult to tune parameters. That's also one factor. And then learns strengths are learns from interactions, adapts to dynamic environments, does not require labeled data. So a lot of other benefits which it is having. There are environments, in fact, I would say, in which reinforcement learning can be implemented. Then there is nothing other, no other, this one machine learning, which can be deployed or implemented in such situations. So this is the best suitable for those. Exploration exploitation trade-off. Exploration, trying random actions in order to find more information about the environment. Exploitation is using known information to maximize the reward. So this is already said, and you can just see on the right hand side, an agent is doing actions on a given, given the state, in an environment, and then receives reward and a new state, definitely. So agent is always trying to maximize the reward. So this is a visual understanding of two things which are there. If you just see the complete concept flow, agent interacts with the environment, it takes actions, receives rewards, updates knowledge, and learns optimal policy, definitely. So final summary, in fact, key points: reinforcement learning through interaction and reward, and then agent improves over time, focus is on decision making, goal is to maximize long-term reward. So definitely all of these things are there. And classification reinforcement learning algorithms. So if we classify reinforcement learning algorithms, they can be classified broadly into these categories. And there are numerous, in fact, reinforcement learning algorithms. You can just say, I can show some of them. It's a huge list. Model free algorithms is one category. Model based algorithms is one more. Based on learning strategy, there are reinforcement learning algorithms. Based on policy type, there are reinforcement learning algorithms. A deep reinforcement learning, modern reinforcement learning, in fact, is the deep reinforcement learning. And based on this also, we are having algorithms. If you just see, there's a huge list. I cannot even just read them out. There are numerous. We are going to discuss here, in this particular series, I think two to three reinforcement learning algorithms. Definitely, one of those would be, based on Q learning. So Q learning is one. What is, first of all, Q learning? So I think, we'll be doing it in the second part of this particular series, that going to Q learning and its deployment in Python and all. So we can just see numerous classification reinforcement learning algorithms which are there. Q learning is one which is at the top, and SARSA, expected SARSA, double Q learning, fitted Q iteration, Monte Carlo prediction, Monte Carlo control on policy, off policy, value iteration, policy iteration. There's a lot of other distributional DQN, noisy DQN, asynchronous advantage actor critique, A3C. A2C is also there, advantage actor critique, and actor critique is also there. Vanilla policy gradient, lot of these reinforcement algorithm, every visit Monte Carlo, first visit Monte Carlo, comma, counterfactual multi-agent policy gradient. So I'm just naming few of them that I could get from this huge list. You can just see this is a huge list. Upper confidence bond, UCB, so trust region policy optimization. There are some of them which are advanced. In fact, we cannot explain these at this level, but when we'll be having a deployment specifically in a particular application area, reinforcement learning, separate series on that. So definitely we try to implement this DQN kind of advanced or deep deterministic policy gradient, DDPG, or such kind of algorithms which are of a higher category, or even some of these double DQN is there, dueling DQN is there, independent definitely hierarchical DQN is there, natural policy gradient is there. So these high level reinforcement learning algorithms will be just getting a chance in case we are definitely we would like to have a separate series on that. We are having, in fact, series on different areas. as far as the application areas of machine learning are concerned. So fraud detection is one of them. In fact, anomaly detection, fraud detection is one more, and then medical diagnosis is one more area, which is in fact a area of interest for me, definitely. So I would be just showing you different machine learning implementations, and if there is any which is in fact, definitely we'll be having one for the reinforcement learning, at least. So in that one we'll be discussing this. In next episode, next in fact part of this episode, which is uh, I believe 17. So we'll be discussing, in fact, the first one, which is Q learning, and we'll go ahead with the deployment. First of all, learning this in complete manner, and then going with the deployment in Python. Thank you so much for joining the session, and I hope this very interesting machine learning type reinforcement learning we had discussed just at a very basic level. So we are just opening it up at least 2 to 3 algorithms in this category, and the basic foundational concepts that are there for reinforcement learning. We are trying to grasp them. Do in fact connect with this in the next part of this episode as well. Subscribe to the channel in case you feel that this is beneficial for you, and you'll be getting notification as and when a new video is uploaded to this. Thank you so much once again for joining, and see you on the other side. Thank you.